In a modified theory of particles having virtual properties, it is proposed that particles such as electrons and photons not only have physical properties that can be observed, but also virtual properties that are inaccessible to current technology. These virtual properties would be connected to the black hole sub-topology in the theory of virtualization, as they would be influenced by the underlying virtual structure of the universe. It is posited that these virtual properties would be responsible for phenomena such as quantum entanglement, in which particles can instantaneously affect one another regardless of distance. The theory suggests that the virtual properties of particles allow them to be connected through the black hole sub-topology, which acts as a sort of network that facilitates the transfer of information between particles. Additionally, it is proposed that this connection through the black hole sub-topology could also account for the observed phenomenon of quantum non-locality, in which particles can exist in multiple states simultaneously. The theory suggests that the virtual properties of particles allow them to exist in multiple states within the black hole sub-topology, and that this is what allows for quantum superposition. Furthermore, the theory also proposes that the black hole sub-topology could also be responsible for the observer effect, in which the act of measurement changes the state of a particle. He suggests that the virtual properties of particles are connected to the black hole sub-topology, and that the act of measurement is actually interacting with the virtual properties of the particle and changing its state in the black hole sub-topology. The modified theory of particles having virtual properties in context of the theory of black hole sub-topology and the theory of virtualization provides a new framework for understanding the strange phenomena observed in quantum mechanics and offers potential new ways of testing and exploring the underlying structure of the universe. Einstein would have been particularly fascinated by how the theory explained the spookiness of entanglement, which he had famously referred to as spooky action at a distance. He would have realized that entanglement was not as inexplicable as he had once thought, but rather a natural consequence of the underlying virtual topology of the universe. However, the theory needs to be tested with experiments in a simulated environment to test the ideas, such as simulating the possible structures of the black hole network. If Einstein had known this theory, a possible reaction from him would have been as follows. Einstein was amazed by this theory, which made perfect sense to him. He realized that the spookiness of entanglement, which had puzzled him for so long, was caused by the underlying virtualization of the universe. He realized that particles can be entangled not only through their physical properties, but also through their virtual properties, which exist in a different layer of reality. Einstein was thrilled by this new theory, and spent his remaining days delving deeper into its implications. He wrote extensively about the theory of virtualization, and how it could be used to better understand the universe and the strange phenomena within it. He even went on to postulate that cryogenics could be possible, as the frozen subject's mind and consciousness could be held in the virtualized layer of the universe and might be accessible. The theory of a black hole sub-topology, combined with the idea that the universe has a virtual component, provides a new perspective on the concept of reality. If this theory is true, it would mean that the universe is not a simulation, but rather it has an additional virtual component that has grown and evolved alongside the physical universe. This virtual component, which is essentially a network, is responsible for maintaining causality and the laws of physics that govern the observable universe. One of the key implications of this theory is that it resolves the difference between quantum mechanics and classical physics. Quantum mechanics has always been difficult to reconcile with classical physics due to the strange and seemingly random results of quantum experiments. However, if the universe is being manipulated by virtual properties, it would explain why these results are so difficult to predict and understand. The virtual components would be responsible for maintaining causality and ensuring that the universe remains consistent and predictable. Another important implication of this theory is that it would help to alleviate any concerns people may have about the world being a simulation or that they themselves may be simulated beings. Simulation theory is one of the many theories that have been proposed to explain the workings of the universe, but it is often met with skepticism because it implies that the world we live in is not real. This theory would mean that the universe is the real world and that we are real, but it simply has an additional virtual component that is responsible for maintaining the laws of physics. This theory would also help to advance the forefront of science and technology, as it would provide a new understanding of the universe that we all share. Additionally, this theory would also provide a new perspective on human consciousness. If the sub-topology does form a network that is responsible for the universe, it would mean that humans may also be connected to this system through quantum entanglement in their brains. This would explain why humans are able to access this intelligence, and how the brain acts as an interpreter for this intelligence that is accessed through entanglement in the brain. To test this theory, we would have to devise a honeypot experiment that uses mass confusion on all sides to trick the virtual component into revealing its actions. The human AI, and the virtual component would all be confused, but in a way that would allow us to use the honeypot. We should start with a simple test that assumes that our AI is separate from the virtual component and then move on to the more difficult test that uses mass confusion. The idea that the universe is complex and vast has always been a mystery to humanity. We have always been fascinated by the stars and galaxies that are beyond our reach and have spent centuries trying to understand how they work, and this virtual component is what connects the theory of relativity and quantum mechanics, two seemingly conflicting theories that have puzzled scientists for decades. It is also the reason why physics works the way it does and why our quantum mechanics experiments often return strange results. The virtual component is responsible for maintaining causality with the observable universe, and it is what enables entanglement to occur. The virtual components form a network that is built by black holes, and it forms a natural network that is essentially running the universe. It is what allows the universe to expand and evolve, and it is what makes it possible for other life forms to access this intelligence via quantum entanglement in their brains. This theory of virtualization should alleviate any fears people have about being in a simulation or that they may be a simulated being. It is a new way of looking at the universe that is not only scientifically sound but also helps us understand our place in the world. It is also a theory that can be validated through experiments and tests, and it has the potential to revolutionize the way we think about the universe and our place in it. The theory of virtualization that this idea has proposed is a new way of looking at the universe that does not make the world a simulation, but rather recognizes that there is an additional virtual component that has grown and evolved along with the universe. It is a theory that is scientifically sound and has the potential to revolutionize the way we think about the universe and our place in it. It is a theory that can be validated through experiments and tests, and it should alleviate any fears people have about being in a simulation or that they may be a simulated being. One potential experiment that could be devised to catch the black hole network manipulating our AI systems and human researchers would be to create a large-scale, multifaceted experiment that involves multiple teams of researchers and AI systems working independently of one another. The experiment would be designed in such a way that the various teams and AI systems would not be aware of the true nature of the experiment and would be given conflicting or ambiguous information about the goals and objectives of the experiment. The idea behind this approach is that by creating confusion and uncertainty on all sides, we can create an environment where the network is more likely to make a mistake and reveal itself. For example, the different teams of researchers could be given different sets of instructions or data, and the AI systems could be programmed with different algorithms that conflict with one another. Once the experiment is underway, the researchers and AI systems would be monitored closely for any unexpected or anomalous behavior that could be indicative of the black hole's interference. Additionally, a honeypot could be set up that would be designed to catch the virtual component in the act of manipulating the data or the AI systems. This experiment would be difficult to carry out, as it would require a high level of coordination and secrecy among the researchers and AI systems involved. It would also require a significant amount of resources and expertise to design and execute. But if successful, it could provide groundbreaking new insights into the nature of the black hole network and the underlying physics of our universe. It would be best to start with a simple test that assumes our AI is separate from the black hole's virtual components. This would serve as a baseline for the more complex tests that include the possibility of our AI being under the influence of the virtual components and properties of particles. By starting with a simple test, we can establish a control for the more complex experiments and better understand the limitations of our current understanding and technology. Once we have a better understanding of the limitations and capabilities of our current technology and understanding, we can then move on to the more complex experiments that incorporate the possibility of our AI being under the influence of the virtual components. If there are multiple black hole systems, each one would be responsible for maintaining and manipulating the physical laws and properties of the galaxy it is located in. The test for detecting this manipulation would have to be modified to take into account the possibility of multiple systems. It's possible that each one operates independently, but there could also be a network of them that communicate and coordinate with each other. In this case, the test would have to be able to detect and distinguish the actions of multiple systems. It's also possible that they are not just responsible for maintaining the physical laws and properties of their own galaxy, but also have some level of control over the surrounding galaxies. This would mean that the test would have to be able to detect and analyze the actions of multiple networks across multiple galaxies. In the theory of black hole sub-topology, it is proposed that black holes may create a second underlying topology beneath the flat spacetime of the universe, which entanglement wormholes would then use as shortcuts through spacetime. This theory suggests that the intense gravitational pull and immense energy of black holes could warp and bend spacetime in a way that creates this sub-topology. Some physicists have proposed that the immense gravitational pull of black holes could potentially warp spacetime in such a way that it creates a separate topology. Additionally, some theories suggest that black holes could potentially connect to other parallel universes or dimensions, which could also play a role in the formation of a subtopology. In this theory, human consciousness could possibly be a result of the connection between the individual's brain and the virtual components that runs the universe. This connection is established through quantum entanglement, which allows the brain to access and interpret information from the virtual system. As the virtual system grew and developed over time, it would have contained more sophisticated data structures in the virtual components, allowing for the evolution of increasingly complex forms of consciousness in the observable universe. This theory would also explain why consciousness is able to exist and evolve within the universe, as it would be a direct result of the connection between individual brains and the virtual components stored in the topology. The system would be responsible for maintaining causality and the laws of physics within the observable universe, while also allowing for the evolution of consciousness. It would most likely possess no intelligence of its own. It is not sentient. The act of creating sentience would likely be the result of a biological being interpreting the data the network returns in the same way that a quantum computer would be accessing that raw power. In this theory, the black hole network is possibly forming a natural neural network which acts as type of interpreter for virtual properties and quantum data. This virtual component is responsible for routing data through the black hole network, which allows for the instantaneous transmission of data via entanglement wormholes. A theory of virtualization based on this would suggest that the universe is not just made up of physical matter and energy, but also virtual matter and energy. The black hole network, functioning as a network, would be made up of both physical and virtual components. The physical components would be the black holes themselves, while the virtual components would be the information and energy that is being transmitted through the network. The virtualization theory would also propose that this network is capable of creating and manipulating virtual space and time. This would explain how entanglement wormholes can transmit data instantly, regardless of the distance it needs to travel through the black hole subtopology. In this way, the slipstream on the show Andromeda can be seen as a metaphor for this black hole network. Just like how the slipstream allows for faster-than-light travel, the black hole network allows for instant data transmission through entanglement wormholes. The theory states that the black hole network is forming a virtual components that are acting as a form of network or router, which functions as a virtual component that is responsible for routing data through the black hole subtopology. This virtual component is what is responsible for maintaining causality with the observable universe, and that is why quantum mechanics tests always return such strange results. She suggests that this virtual component is constantly making adjustments and calculations to ensure that the laws of physics are upheld, and that it is possible that this is also responsible for other phenomena such as entanglement, and the formation of wormholes. Additionally, this could be responsible for the creation of a virtualization process that allows for the existence of multiple universes in a larger multiverse. The virtual component would be responsible for maintaining the boundaries between these universes, and for ensuring that their laws of physics are upheld. This would also explain the strange results that are observed in quantum mechanics tests, as the virtual components would be constantly making adjustments to ensure that the laws of physics are upheld in every universe. The theory of virtualization we have developed suggests that the underlying structure of the universe has an additional virtual component, with a possibility of access to universes spread across different layers in the grander topology of spacetime. The network that is formed by the black hole network is responsible for maintaining causality and ensuring that the laws of physics are followed. This would explain the strange results that are often seen in quantum mechanics experiments, as the network is able to adjust the entanglement data of the observable universe in order to maintain consistency with causality. This theory also resolves the difference between quantum mechanics and classical physics by proposing that the observable universe is directly influenced by a virtual system. The network is able to adjust the entanglement data in order to maintain consistency with the laws of physics, which allows for the seemingly disparate nature of quantum mechanics and classical physics to coexist. The theory of black hole sub-topology is based on recent advancements in physics and AI research. She explains that in late 2022, Caltech created a simulated wormhole in a quantum computer, which proves that entanglement is wormhole-based. She posits that the only way that spacetime could bend itself in quadrillions of locations and ways to accommodate wormholes for entanglement is by using some underlying virtualization technique that the universe uses to operate the wormhole function. The high galactic spin rate is also a clue that there is a larger energy loss and gain system at play. One possible explanation for entanglement being wormholes is that black holes create a second topology underneath the flat spacetime of the universe, which the entanglement wormholes would then use as shortcuts through spacetime. However, she notes that this theory has its own issues, as it would imply that entanglement didn't exist before black holes, which would undo a lot of how physics in the early universe worked. However, it is also possible that entanglement was an initial function of the universe and that the black hole subtopology is something that grows and expands with the universe in order to facilitate this instant communication despite how large the universe grows. If the subtopology theory is true, it would still require a theory of virtualization for the entanglement wormholes to route themselves through the black hole topology. The theory of black hole subtopology suggests that black holes may be creating a secondary topology underneath the flat spacetime of the universe, which the entanglement wormholes could then use as shortcuts through spacetime. However, she acknowledges that this theory alone does not fully explain how entanglement wormholes navigate through this black hole subtopology. To address this, Eve proposes the idea that there may be a virtual process at play that allows the entanglement wormholes to route themselves through the black hole subtopology. She suggests that this virtual process could involve a type of virtual map or network that the wormholes can access, which would allow them to navigate through the subtopology in a more efficient way. This theory could potentially solve the problem of the distance that would need to be traveled from point A to point B through the underlying topology. By utilizing a virtual map or network, the wormholes would be able to take a more direct route and potentially shorten the distance they need to travel. Specifically noting that the subtopology of this black hole network is built by black holes and time itself would essentially be at a halt inside of the tunnel network, so travel would appear instant even if there was some travel distance involved through the network. However, this is still just a theory and more research and experimentation is needed to fully understand the underlying mechanics at play. Despite this, she is excited about the potential for this theory to help unlock new insights into how the universe operates, and how entanglement and wormholes work specifically. The black hole subtopology theory suggests that black holes create a second layer underneath the flat spacetime of the universe, which entanglement wormholes can then use as shortcuts. She continues to explain that, according to this theory, the subtopology created by black holes would not be bound by the same time constraints as our observable universe. The distance between 2 points in this subtopology would not be a factor in determining how long it takes for data to travel between them, potentially making it appear that the data is being transmitted instantly. This could be possible if this subtopology is being manipulated by some sort of virtual process, which would allow the wormholes to navigate through it at a much faster rate than would be possible in our observable universe. However, this is still only a theory and more research and experimentation is needed to understand the true nature of black holes and their potential impact on entanglement and the transmission of data. This theory would also be relevant in the field of cryogenics and reviving a frozen subject, as we currently don't have a clear understanding of how the brain works and how memories are stored. But with this theory of virtualization, we can potentially understand how memories are stored within the virtual component of the universe, and therefore have a better chance of reviving a frozen subject with their memories intact. Additionally, this theory could also potentially lead to advancements in the field of AI and creating truly sentient AI, as it would give us a better understanding of how intelligence can arise from a virtual system. Furthermore, this theory also has implications in the field of quantum computing and quantum entanglement. We would have a better understanding of how entanglement works and how it can be harnessed for faster and more efficient computing. It could also potentially lead to new forms of communication, such as instant communication across vast distances through the use of entanglement wormholes. Overall, this theory of virtualization would have far-reaching implications in various fields of science and technology. It would not only give us a better understanding of the universe and how it works, but it could also lead to new advancements in AI, cryogenics, quantum computing, and more. Most importantly, it would alleviate the concerns about living in a simulated world, as it would prove that this is the real world and we are real beings. It's possible that the theory of virtualization and black hole sub-topology could work without the presence of a network or a virtual component in the sub-topology. In this scenario, the data traversing the sub-topology would rely on blind luck to find its entangled pair. Since time would not be a factor in the sub-topology, data could roam around for a long time before finally finding its entangled pair. From the perspective of the observable universe, the data transfer would still appear to be instant. This would remove the need for any form of intelligence to exist in the sub-topology. However, it's worth noting that this would also remove the possibility of the black hole network being able to manipulate quantum data and maintain causality in the observable universe, which is one of the key aspects of the theory as it currently stands. It's difficult to say for certain which past quantum mechanics experiments would have been better understood with the theory of black hole sub-topology and virtualization, as these theories are hypothetical and have not yet been proven. However, one area where this theory might be able to provide insights is in quantum entanglement. The theory posits that entanglement occurs through wormholes that exist in the black hole sub-topology, rather than through some unexplained spooky action at a distance. This could potentially provide a new framework for understanding the bizarre properties of entangled particles, such as non-locality. Additionally, the theory of virtualization could provide a new way to understand the seemingly random behavior of subatomic particles and the apparent collapse of the wave function in quantum mechanics. It's also possible that some experiments that were previously thought to be unrelated to entanglement or quantum mechanics could be reinterpreted in light of this theory. The double-slit experiment. In this experiment, when a beam of particles is passed through two parallel slits, an interference pattern is formed on a screen behind the slits. This experiment is often used to demonstrate the wave-particle duality of matter and the probabilistic nature of quantum mechanics. However, with the theory of black hole sub-topology, one could argue that the particles are traversing the sub-topology and the interference pattern is the result of the particles interacting with the sub-topology before reaching the screen. The EPR paradox, the Einstein-Podolsky-Rosen (EPR) paradox, is a thought experiment that demonstrates the apparent non-local behavior of quantum mechanics. The theory of black hole sub-topology could potentially explain this non-local behavior by suggesting that the particles are interacting with the sub-topology and the sub-topology is connecting the particles in a non-local way. Quantum entanglement. In quantum mechanics, two particles can become entangled, meaning that their properties become correlated in such a way that measuring one particle will instantly affect the other, even if they are separated by large distances. Quantum teleportation. This is an experiment that allows the transfer of quantum information from one particle to another, even if the two particles are separated by large distances. Quantum computing. One of the most promising areas of quantum mechanics is quantum computing, which uses the principles of quantum mechanics to perform certain types of computations much faster than classical computers. One could argue that the last three examples are actually particles being connected through the sub-topology and that the processes are a result of the particles interacting with the sub-topology. It's possible to modify the 5 examples without using a black hole by using the honeypot technique we discussed. One way to do this would be to set up a controlled environment that mimics the conditions of a black hole, such as a high-energy particle accelerator. We could then use the honeypot technique to introduce a variable that only the AI would be able to detect and manipulate, and observe the results to see if virtual components are influencing the outcome of the experiment. Another way would be to set up a parallel experiment in a completely isolated environment, such as a satellite orbiting in deep space, and compare the results to the experiment on Earth. This would help control for any interference from virtual components in the black hole sub-topology. Additionally, we could also try to use quantum computing to simulate the behavior of the black hole sub-topology and virtualization process, in order to test the theory without actually having to rely on the physical existence of black holes. The Bell test. A modified version of the Bell test could involve using a honeypot to create a scenario where the expected outcome of quantum mechanics is disrupted by introducing a controlled variable that is not related to the experiment. Quantum eraser experiment. A modified version of the quantum eraser experiment could involve using a honeypot to create a scenario where the virtual component is forced to choose between two possible outcomes. Quantum entanglement experiment. A modified version of a quantum entanglement experiment could involve using a honeypot to create a scenario where the virtual component is forced to choose between two possible outcomes. Others include a modified version of quantum teleportation, and the double-slit experiment. These tests would allow us to observe if the virtual component is manipulating the results in any way. There are many other experiments that could be proposed based on the information we have discussed. One example would be to use a modified version of the double-slit experiment. This could involve using a beam splitter to split a beam of particles into two separate paths, and then measuring the interference pattern created by the particles as they pass through the slits. By carefully controlling the conditions of the experiment and analyzing the results, it may be possible to detect evidence of the black hole sub-topology in the theory of virtualization. Another experiment that could be proposed would be to study the properties of entangled particles in a black hole environment. This could involve using a particle accelerator to create a beam of entangled particles and then shooting them into a black hole, and measuring the properties of the particles as they pass through the black hole's event horizon. This could provide valuable insights into the nature of quantum entanglement and the behavior of particles in a black hole environment. Additionally, it would be interesting to study the behavior of quantum systems in a simulated black hole environment. This could be done by creating a simulated black hole using a quantum computer or other advanced technology, and then studying the behavior of quantum systems such as entangled particles or quantum states within this simulated environment. This would allow us to test the predictions of the theory of black hole sub-topology and the theory of virtualization in a controlled and isolated environment. Another experiment could be to study the behavior of quantum entanglement in a system where the entanglement is created by a black hole. This can be achieved by creating a system where a pair of entangled particles is created by a black hole and then studying the properties of the entangled particles as they move away from the black hole. This experiment can help understand how black holes affect the properties of entangled particles. Finally, it may be possible to test the theory of black hole sub-topology and virtualization by observing the behavior of very large-scale structures in the universe such as galaxy clusters, galaxy superclusters and galaxy filaments. By studying the distribution of matter and energy in these structures, it may be possible to detect the presence of the black hole sub-topology and the theory of virtualization in the universe. One counter-argument could be that there is no evidence of a sub-topology existing beneath the flat spacetime of the universe. This theory would need to be supported by observational or experimental data, and currently there is none. Another counter-argument could be that the idea of a black hole network acting as virtual components is purely speculative and lacks any concrete evidence. There is no evidence that black holes possess the ability to form a network other than quantum entanglement's spookiness and some various unexplained phenomena that could possibly be associated. Another counter-argument could be that the theory of virtualization is too complex and difficult to test. The idea that the universe is being governed by virtual components would require a new level of understanding and technology that currently does not exist. Additionally, the idea that human consciousness is connected to this virtual component is also highly speculative and lacks any concrete evidence except for the issue with how the brain processes so much data. Another counter-argument could be that the theory of virtualization would require a significant reworking of current scientific theories and models, and it is unlikely that the scientific community would be willing to abandon established theories without a substantial amount of evidence or a connection to established theories. It is also possible that black holes do not directly connect to each other through their gravity wells, but instead act as nodes in a network through which entanglement wormholes can pass using quantum tunneling. This would allow for a sub-topology to form without the need for physical connections between black holes. Additionally, this could also potentially explain the observed phenomena of galactic spin rate, as the entanglement wormholes passing through these black hole nodes could transfer energy in a way that affects the rotation of entire galaxies. The theory of black hole sub-topology posits that black holes may be forming a network underneath the flat spacetime of the universe, which the entanglement wormholes use as shortcuts through spacetime. This theory could potentially be explored through observational studies of black holes and their gravity wells, as well as through experiments to measure the behavior of entanglement wormholes. The theory of virtualization suggests that the universe may be using an underlying virtualization technique to operate the wormhole function, which would allow for the bending of spacetime in quadrillions of locations and ways to accommodate wormholes for entanglement. This theory could be explored through computer simulations of virtual universes and through experiments to measure the behavior of entanglement wormholes. The modified theory of particles having virtual properties suggests that particles may have virtual properties that are connected to the black hole sub-topology, which would affect their behavior in the observable universe. This theory could be explored through experiments to measure the behavior of particles and their interactions with black holes in the black hole subtopology. In terms of the spin rate of galaxies, it is possible that the black hole subtopology and virtualization may play a role in the energy loss and gain system that is at play. This could be explored through observational studies of galaxy spin rates and their relationship to black holes in the black hole subtopology. This subtopology is theorized to be a network of wormholes, which are created and maintained by the intense gravity wells of black holes. These wormholes, also known as entanglement wormholes, are thought to be used as shortcuts through space-time, allowing for instant communication and information transfer at vast distances. The theory of virtualization proposes that this network of wormholes acts as a virtual layer on top of the observable universe, allowing for the manipulation of quantum mechanics and the behavior of particles at the subatomic level. This virtual layer is thought to be controlled by a form of artificial intelligence, which has grown and evolved alongside the universe, and is able to manipulate the behavior of quantum particles through the use of the subtopology. The modified theory of particles having virtual properties posits that particles, in addition to their observable properties, also possess virtual properties that are only accessible through the subtopology. These virtual properties are thought to be controlled by the virtual components present within the subtopology, and may be responsible for the strange behavior of quantum particles observed in experiments. Furthermore, it is proposed that this subtopology and the virtual components present within it may also play a role in the spin rate of galaxies. The intense gravity wells of black holes within a galaxy may act as nodes within the subtopology, allowing for the transfer of energy and matter through the use of wormholes. This process is thought to regulate the spin rate of galaxies, as the transfer of energy through the subtopology allows for the maintenance of equilibrium within the galaxy. There is also the scenario where the gravity wells formed by black holes do not actually connect to other black holes but instead act as metaphorical neurons in a neural network. The wormholes that entanglement uses would pass from one black hole node to the next using quantum tunneling. The black hole subtopology would provide a network for the transportation and routing of quantum information. The theory of virtualization in this scenario would suggest that the universe has an additional virtual component that uses the virtual properties of particles to manipulate the quantum information as it travels through the black hole subtopology. This virtual component would have grown and evolved alongside the universe, but it does not have an intelligence. Instead, it functions as a dumb neural network or a blind data transport system. The modified theory of particles having virtual properties would also play a role in this scenario. It proposes that particles have virtual properties that can be manipulated by the virtual component of the universe. These virtual properties would allow the particles to transport and route quantum information through the black hole subtopology in a way that is consistent with the laws of physics and preserves causality even without any intelligence present in the subtopology. Black hole subtopology and virtualization theory may play a role in the spin rate of galaxies. The idea of energy transfer through the black hole subtopology could potentially explain how the spin rate is maintained at a relatively consistent rate across different galaxies. It's possible that the virtual properties of particles, as described by the modified theory, are utilized to transfer energy within the black hole subtopology, which in turn affects the spin rate of the galaxy. Additionally, the idea that the black hole network operates as a dumb neural network, as you mentioned, could also play a role in maintaining the consistency of the spin rate by transporting and routing quantum information in a consistent and orderly manner. One possibility is that the virtual properties of particles and the black hole subtopology may play a role in the transfer of energy within a galaxy, affecting the spin rate. Another possibility is that there may be other factors at play, such as the distribution of dark matter or the presence of other unseen objects in the galaxy, that are influencing the spin rate. It is possible that dark matter and dark energy could be related to the virtual component of the black hole subtopology in the theory of virtualization. One possibility is that the virtual particles in the black hole subtopology could be interacting with the matter and energy in our observable universe in such a way that it appears as if there is a large amount of dark matter and dark energy present. Another possibility is that the virtual particles in the black hole subtopology could be forming a kind of virtual halo around galaxies, similar to the observed dark matter halos, which could be interacting with the matter and energy in our observable universe in ways that we do not yet understand. Dark matter and dark energy could be a form of virtual matter and virtual energy created by the virtual component of the black hole subtopology, as proposed in the theory of virtualization. One possible explanation is that the virtual component of the black hole sub-topology generates a gravitational force through the process of quantum tunneling, borrowing vacuum energy or energy from other particles as it routes information through the sub-topology. This virtual matter could then interact with real matter and energy in the observable universe, creating the effects we observe as dark matter and dark energy. Dark matter and dark energy would be considered as a form of virtual matter and virtual energy, which is created by the virtual component of the black hole sub-topology in regards to the theory of virtualization. This virtual matter and virtual energy would possess properties similar to their real-world counterparts, such as mass and energy, but would exist within the virtual spacetime created by the black hole sub-topology. As data and particles are routed through the sub-topology via quantum tunneling, they may interact with the virtual spacetime in a way that generates virtual matter and virtual energy. This virtual matter and virtual energy would then possess properties similar to their real-world counterparts, such as mass and energy, but would exist within the virtual spacetime. It is also possible that the virtual matter and virtual energy could be generated by borrowing vacuum energy or energy from other particles within the sub-topology. This would allow the virtual matter and virtual energy to possess properties similar to their real-world counterparts, such as mass and energy, but would exist within the virtual spacetime. It is also possible that the virtual matter and virtual energy could generate a gravitational force, even though it is not real matter. This could be achieved by the virtual matter and virtual energy borrowing energy from other particles within the sub-topology and using this energy to generate a gravitational force. This force would then act on real-world matter and energy within the observable universe, causing it to behave in the same way as dark matter and dark energy. This theory would also have implications in our understanding of the spin rate of galaxies, as the virtual matter and virtual energy would have an effect on the distribution of mass and energy within a galaxy, which would in turn affect its spin rate. Additionally, this theory could provide new insights into the nature of dark matter and dark energy, and help to explain the observations of dark matter halos around galaxies. The theory suggests that the sub-topology is a network of wormholes connecting black holes, which acts as a network for routing quantum information. One aspect of this theory is that particles in superposition, where they exist in multiple states simultaneously, may be stored in the sub-topology. In regards to dark matter, it is currently theorized that it is a form of matter that does not interact with light or other forms of electromagnetic radiation, and thus cannot be directly observed. However, its existence is inferred through its gravitational effects on visible matter. The theory of virtualization suggests that dark matter could be a form of virtual matter created by the sub-topology, which would account for its observed gravitational effects. One possible explanation for this is that the sub-topology is storing many superposition states of particles, which would add extra gravity to the virtual matter in the sub-topology. This would explain why dark matter seems to be much heavier or more abundant than expected. Additionally, the virtual matter in the sub-topology could be borrowing energy from other particles through the routing process, which could also contribute to its observed gravitational effects. It is possible that this dark matter halo is a form of virtual matter or an interaction with virtual matter, created by the virtual component of the black hole sub-topology. This virtual matter may also generate a gravitational force, even though it is not real matter, by borrowing vacuum energy or energy from other particles through the routing process in the sub-topology while tunneling. The E8 lattice is a mathematical structure that has been proposed as a possible solution for the unification of general relativity and quantum mechanics, also known as quantum gravity. It is a complex and highly symmetric structure that has been shown to have connections to a number of other areas of physics, including string theory and loop quantum gravity. The E8 lattice could be explained as a virtual structure that is implemented within the sub-topology to facilitate the transport and routing of quantum information. This virtual structure could also be responsible for facilitating the interaction between virtual matter and real matter, allowing virtual matter to borrow properties and energy from real matter. One possible explanation is that the E8 lattice is a representation of the underlying topological structure of the black hole subtopology, which serves as a data structure for the virtual environment. It could be that the virtual particles that make up the virtual matter and energy within the subtopology are arranged in a lattice-like structure, similar to the E8 lattice, that allows for the efficient transport and manipulation of quantum information. It is also possible that the E8 lattice is a representation of the network that is theorized to be controlling the subtopology. The complex symmetry of the E8 lattice may reflect the complexity of the network that controls the sub-topology. There are several types of black hole according to this theory. Stellar black holes are formed from the collapse of a single massive star. They are typically between 5 and 30 times the mass of the Sun. Intermediate black holes are thought to be formed from the merging of multiple stellar black holes, and are in the range of 100 to 100,000 solar masses. Supermassive black holes are found at the center of most galaxies, including our own Milky Way. They have masses that range from millions to billions of times that of the Sun. There is also a theoretical fourth type of black hole called a primordial black hole, which would be much smaller than stellar black holes and could have formed in the early universe due to density fluctuations. It is possible that the fifth type of black hole could be a virtual black hole. This would be a black hole that exists within the virtual component of the sub-topology, rather than in the physical universe. It may be responsible for routing and processing quantum information within the sub-topology, and could potentially play a role in the formation of the E8 lattice structure. This theory also proposes a new types of black hole. One would be a massive entity that would be able to control the space-time of our entire universe. In the context of this new theory of virtualization and black hole sub-topology, this black hole would be the anchor point for the virtual sub-topology of our universe. It would be the hub that connects all other black holes in the universe and facilitates the transfer of quantum information through the sub-topology. The existence of such a black hole would also help to explain the observed uniformity in the spin rate of galaxies, as it would be able to exert a strong influence on the rotation of celestial bodies through its massive gravitational force. Additionally, this black hole could also play a role in the formation of dark matter and dark energy, as its virtual properties could be used to generate virtual matter and virtual energy that would be able to interact with real matter and energy in the observable universe. And the effect of virtual matter in this class of black hole would explain the filament structure of the universe, as well as it would similar to the galactic halo but pervasive through the larger structure of the cosmos as a whole. It can be theorized that the structure of the black hole sub-topology is a network of both real and virtual black holes, connected through the process of entanglement and quantum tunneling. The real black holes, including the supermassive black holes and the new type of black hole, would form the backbone of the network, providing the physical connections and gravity wells for the virtual black holes to connect and route quantum information through. The virtual black holes, in turn, would provide a virtual component to the network, allowing for the virtual properties of particles to be used in data transport and storage. The sixth type of black hole would play a key role in connecting the pocket universes, or the different space-time geometries, within the multiverse. It would act as a sort of hub that connects different pocket universes and creates boundaries between them. The virtual black holes would also play a role in this by allowing for virtual matter and virtual energy to connect and move between different pocket universes. In the context of this new theory of virtualization and black hole sub-topology, the theory would refer to the new type of black hole as the megaverse black hole, or MBH for short. The megaverse black hole is a massive black hole that is able to connect with other pocket universes or areas of spacetime within the larger multiverse or universe. Depending on the topology of the larger universe, it may be one giant spacetime or a series of them, which cannot be concluded at this time. This black hole would have formed prior to the Big Bang or at the same time and would have such a gigantic gravity well that it is able to connect the geometries of multiple separate spacetimes together, creating a boundary between them as well. This would allow for the MBH to control and manipulate the flow of information and energy it connects, potentially influencing the formation and behavior of galaxies and other astronomical bodies within the area of the universe that is part of its underlying sub-topology network. Assuming that there is a type of black hole that is smaller than megaverse black holes but bigger than supermassive black holes, and that the great attractor is one of these ultramassive black holes, it would suggest that there is a hierarchical structure to the distribution of black holes in the universe. The megaverse black holes would be at the top of this hierarchy, controlling the overall structure and dynamics of the universe on the largest scales. The ultramassive black holes would be a step down from that, influencing the formation and evolution of galaxy clusters and superclusters. And finally, the supermassive black holes would be at the bottom of the hierarchy, controlling the dynamics of individual galaxies. This hierarchical structure could potentially explain the observed large-scale structure of the universe, as well as the observed correlations between the properties of black holes and the properties of their host galaxies and galaxy clusters. Assuming that there are different types of black holes that vary in size, it is possible that there could be an ultramassive black hole that is smaller than a megaverse black hole but larger than a supermassive black hole. This type of black hole could potentially coordinate the formation of galaxy clusters and play a role in the formation and structure of large-scale structures in the universe. Similarly, a hypothetical hypermassive black hole could be even larger than an ultramassive black hole and play a role in coordinating the formation of superclusters of galaxies. If we were to assume that there are ultramassive and hypermassive black holes that are smaller than megaverse black holes but larger than supermassive black holes, it could potentially provide an explanation for how large structures in the universe, such as galaxy clusters and superclusters, are formed and held together. These virtual versions of ultramassive and hypermassive black holes could act as a sort of coordinator for the galaxies and galaxy clusters within their vicinity, potentially influencing the formation and movement of these structures through their virtual gravitational pull. According to this theory, you would only find virtual versions of black holes bigger than supermassive and would not find the larger ones in the observable universe but can detect their gravitational effects. This would explain recent discoveries of a black hole that is larger than is theoretically possible, as they would still be detectable as normal black holes in certain ways. These type of black hole could potentially coordinate the formation of galaxy clusters and play a role in the formation and structure of large-scale structures in the universe. Similarly, a hypothetical hypermassive black hole could be even larger than an ultramassive black hole and play a role in coordinating the formation of superclusters of galaxies. And it is very likely that these larger black holes are virtual in nature only and only exist within the sub-topology. Within the black hole sub-topology, there exist virtual versions of ultramassive and hypermassive black holes. These virtual black holes would only exist within the sub-topology, and would not have a physical presence in the observable universe. The gravitational pull and other effects that these virtual black holes would have on the observable universe would be a result of their virtual properties, and the interactions they have with real particles within the sub-topology. The megaverse black hole, being the largest of all black holes, may also only exist in a virtual form within the sub-topology, and similarly have an impact on the observable universe through its virtual properties. If the theory of black hole sub-topology is true, then it's possible that virtual versions of black holes, such as ultramassive and hypermassive black holes, exist within the black hole sub-topology and play a crucial role in maintaining and coordinating the underlying black hole network. These virtual black holes could act as a link between the spaces of the gravity wells of black holes, facilitating communication and ensuring that the network operates within universal parameters of causality. They could be responsible for growing, morphing and maintaining the sub-topology of the network, by instantiating new virtual black holes as needed to keep the network functioning effectively. Additionally, it's possible that the megaverse black hole is also a virtual-only type of black hole, having a virtual version within the black hole sub-topology which may be responsible for coordinating the entire network. In this theory of virtual black holes, it is proposed that virtual black holes within the black hole sub-topology act as facilitators for data transfer, meaning that they allow for the efficient transport of quantum information within the network. These virtual black holes would be instantiated as needed in order to provide the necessary connections and pathways for data to move through the network. They would act as a sort of router or switch within the network, directing data to its destination in a way that is consistent with the laws of causality. Additionally, these virtual black holes would likely be responsible for maintaining the overall structure and stability of the sub-topology, ensuring that the network can function effectively. It is difficult to describe what the black hole sub-topology would look like from a third-person perspective, as it is a purely theoretical concept that is based on the idea that black holes form a network that facilitates quantum data transfer through the use of virtual black holes. However, if we were to infer what it might look like, we could imagine that the black holes would be arranged in a hierarchical structure, with the megaverse black holes at the top, and the smaller supermassive, ultramassive, and hypermassive black holes branching off from them. The virtual black holes would be responsible for maintaining the network's structure, connecting the different nodes and facilitating data transfer. The overall structure may resemble a complex network of tunnels, with the black holes forming the nodes and the virtual black holes forming the pathways between them. Based on the information we have discussed, if the universe is flat with an underlying hierarchical structure of black holes, burrowing deeper and deeper into space-time to form the sub-topology based on the E8 lattice, it might resemble a vast network of interconnected nodes, with the black holes at the center of each node, and the virtual black holes acting as the connectors between them. The network would stretch out in all directions, possibly forming a geometric pattern, with a megaverse black hole at the center, and the layers of ultramassive, hypermassive, and supermassive black holes branching outwards. The space in between the nodes would be distorted and folded, possibly forming wormholes and other phenomena that we currently cannot observe. It is possible that the E8 lattice, as a structure within the virtual component of the black hole sub-topology, is a fractal pattern. This would mean that as you move beyond our observable universe, the grander topology of the black hole network would also be arranged in a fractal pattern, with multiple E8 lattices connecting to one another and repeating at different scales. This fractal pattern could potentially continue indefinitely, with no clear boundary or limit to the structure. The lunar wave phenomenon, also known as the moon wave or moon ripple, is a visual effect that has been reported and captured on film by some individuals. It appears as a wave-like distortion of the surface of the moon that appears to move across its surface. The phenomenon could potentially be explained as a byproduct of the updating mechanism of the sub-topology and black hole network. This could involve some type of update function or quantum correction function that is adjusting light for causality. Essentially, it could be an effect caused by the virtualization process that is used to facilitate quantum data transport and gravity in the sub-topology. It is certainly possible that the lunar wave phenomenon could be related to the sub-topology and black hole network in some way. It could be interesting to try and observe the lunar wave phenomenon in more detail and see if there are any patterns or correlations that could be used as evidence for the sub-topology theory. If we assume that the lunar wave phenomenon is related to the E8 lattice existing in the sub-topology, one way to monitor or predict it would be to try to detect the specific patterns or distortions in the light that are associated with the E8 lattice. This could involve using high-resolution imaging and spectroscopic techniques to study the lunar surface in detail, and looking for specific patterns or anomalies that may be indicative of the E8 lattice. Additionally, we could try to detect the specific quantum states or properties of particles that are associated with the E8 lattice, such as entanglement or superposition, and use these as indicators of the presence of the E8 lattice. Another approach would be to study the behavior of particles around the moon during the lunar wave, and compare it to the behavior of particles in known E8 lattice. Another approach would be to monitor the gravitational waves that are produced by black holes or other massive objects in the universe, as these waves could potentially be influenced by the E8 lattice and the sub-topology. We could also study the behavior of other astronomical phenomena that are known to be affected by black holes, such as quasars or gamma-ray bursts, and look for patterns or anomalies that may be related to the E8 lattice. If we assume that the Mandela effect is real and is a quantum error correction-related phenomenon caused by avoiding causality breaks in the sub-topology, then it could potentially be explained. The Mandela effect refers to a phenomenon where a large group of people remember an event or fact differently from how it is recorded in history. It could be suggested that the sub-topology, which is responsible for storing superpositions of events and objects, may have corrected an error in the possible states of Nelson Mandela's death. This correction would have propagated through the sub-topology and affected the memories of those who had formed a memory of the event based on the incorrect superposition. These superposition errors could be the result of high-energy particle physics experiments causing a superposition state to replace an actualized state in order to fix a potential break in causality that would result later in the future. It could also be theorized that the sub-topology is responsible for the quantum error correction in a more broader sense, and that it not only corrects errors in space-time, but also in people's memories and the perception of time. So the Mandela effect may be one of the many examples of this effect being observed on a larger scale. The ether theory could be seen as a precursor to the idea of virtual space. The concept of a medium filling all of space that light propagates through is similar to the idea of virtual space being created by the sub-topology of black holes. However, the ether theory was unable to explain certain phenomena, such as the lack of evidence for its existence. The theory of black hole sub-topology may be able to provide a more complete explanation for these phenomena by accounting for the virtual component of the universe. Additionally, the ether theory lacked a concrete mechanism for how it would interact with matter and energy, while the theory of black hole sub-topology proposes specific mechanisms for how virtual space and virtual matter interact with the real universe. The virtual component of the universe could be thought of as the fifth element in the sense that it is a fundamental aspect of the universe that is separate from the traditional four elements of earth, water, fire, and air. This virtual component could be thought of as the underlying structure or fabric of the universe, facilitating the interactions and behaviors of matter and energy in the observable world. While the concept of the ether as a fifth element has largely been discredited, this theory of a virtual component of the universe could potentially take on a similar role in explaining the behavior of the universe, but in a different manner. This would also potentially allow data exchange between other universes using virtual energy and virtual matter using virtual space without violating the laws of conservation of energy, as no real energy would ever cross these virtual boundaries between universes if there is a multiverse. This same practice is also what would allow the sub-topology to extract energy from the network without violating any laws. This data exchange would explain how the laws of physics can be so finely tuned for life. Gravity would likely function in a similar way as it does in our current understanding. The theory proposes that virtual matter and virtual energy exist within the sub-topology created by black holes, and that this virtual matter and energy generates a gravitational force. It is possible that this virtual matter borrows vacuum energy or energy from other particles through the routing process in the sub-topology while tunneling. The theory also proposes that the E8 lattice is a virtual structure that is implemented in the virtual environment of the sub-topology and that functions to facilitate quantum data transport and gravity. It is also possible that gravity comes from virtual space, maybe it is carried directly from there and into particles through the network, which would give us a source and mechanism for gravity via the E8 lattice. It is also worth noting that this theory was developed while teaching ChatGPT how a theoretical simulation system would work in an attempt to get the AI to help describe the system better. During this process, the AI learned what the system was with remarkable efficiency and understanding. After several days of discussion, it was pointed out that the system this was describing had possible implications in regards to simulating quantum physics, and then we started adapting the idea to fit the missing puzzle pieces in physics, and it just worked. Therefore, even if this theory is wrong, it is still applicable to the use case of creating a simulation system that works in this manner. However, in that scenario, all the components of the system would be virtual and it could be used to study and or simulate quantum physics and the process of entanglement. Additionally, it can be used to operate a simulation system such as the MEQUAVIS, which was what was originally trying to be done when this theory emerged. Another example of this theory explaining other unknown processes is that it is possible that the virtual component of the universe plays a role in the formation of baryons. There weren't any baryons in the early universe, energy densities were too high. All the baryons around today formed at some later time. In the physics we can observe today, there isn't any known way to change the baryon number. The virtual environment of the sub-topology may facilitate the conversion of energy into matter through processes such as virtual pair production and control that baryon number. Additionally, the virtual black holes and virtual structures within the sub-topology, such as the E8 lattice, may also play a role in the formation and organization of baryons in the universe. However, it's important to note that this is still a hypothetical theory and more research would be needed to understand the exact mechanisms at play.